Hello guys, you're welcome to Staadpro. In today's class, we are going to be treating a vertical vessel foundation. Previously we have been doing general mode, which is where we design all the common foundation like isolated footing, combined footing, mat foundation, fire cap, fire cap, and all those common ones. Okay, then this one is going to be, we're going to be exploring plant mode. The plant mode will give us access to design vertical vessel for those in oil and gas companies or servicing companies who designs foundation for all these guys, all these IOCs or servicing companies. They have a lot of vertical vessels and horizontal vessels. Tank foundation for the tank farms and lateral analysis of drill hire. So we are going to be designing one of the vertical vessels. Before we continue, let me quickly give you an update on my Staadpro training course. I have actually updated it. I added some bonus packages. Let me just quickly show you through. Okay, so this is my channel. So if you look at this particular video, okay, 12 days Staadpro training with bonus packages. So let me show you the bonus packages I have added to the Staadpro training course. Okay, so the bonus packages are three in number. We have the first one as a pile analysis and design, determination of pile cap, which the report includes the PY course and all the necessary checks. Is a bonus package. You have also the pile cap analysis and design. Pile cap analysis and design. You also have a 7-story concrete building design, complete design from start to finish. So this 7-story building is a concrete design. I know you have a personal project, may have a personal project. This will show you how you go about your personal project, starting from the architectural drawing down to the modeling in Staadpro, loading, member properties, loading, load combination, wind loads, analysis and design. So in design we use the, of course, RCDC, Staadpro RCDC for all the concrete members like slab, beam, column. We even did demonstrated how to design foundation with Staadpro RCDC. So, and you know that this course covers everything, both concrete, steel, steel connections, and the rest of them. So, if you buy this course, you're going to learn Staadpro itself. You're going to learn RCDC. You're going to learn RAM connection. That's for connection, steel connection design. You're going to learn Staadpro Foundation Advanced, just like 4 software in one. So when you buy these products, you're going to be good with Staadpro in all aspects. So there's nothing you cannot design, both concrete and steel, then foundation as well. So I've also added. I have common foundations here demonstrated. I have part foundation, double fitting, mat foundation. I have all of them here. Then this pile and pile cap foundation is another is added advantage for you. So this is well arranged. So if you buy this product, you're not going to regret it. You're going to thank me for it. I've not increased the price. The price has been what it is since last year, so I've not increased the price. And I just wanted to just give a kind of this, to just give this bonus to some of you who might be interested. And very soon I'm going to take the price up, because these bonuses and the value of this package is not supposed to be that price, because the price is not quite much. It's just a small token, so after some time I'm going to increase it. So if you need it, the earlier the better. If you get it now, fine. But if you wait, tomorrow might be too late for me to for you to get it, because the price might go to the normal rate. Okay, let's quickly dive into today's task. So for the plant mode, just click on this plant icon. Once it is open, okay, let's wait for it to open completely. Okay, so under this job information, you see these are the foundations we can do under this plant mode. We have create vertical vessel foundation, create a horizontal vessel foundation, create tank foundations. We want to do tank foundation, then create drilled or driven foundation. That's for pile analysis and design. So in my training course, we have covered this one. We have covered everything about drilled pile foundation analysis and design of pile. So today we are going to treat this vertical vessel. So I will just click on the vertical vessel. Okay, so this is the preview of the vertical vessel. In oil and gas, we have a lot of vertical vessels. We have scrubbers. We have a lot of vertical vessels. It's either it is vertical or it's horizontal. For some vessels, we have bent stack and the rest of them that are vertical, and so many of them, so many vessels in oil and gas. So if you are in oil and gas and you are hoping to be there, this course is for you. Okay, so the vertical vessel ID, you can just leave it like that, or you give it another name. Okay, so the unit system, I will use SI units. Okay, then design code, we have US and Indian code. These two codes are the only one available, so I will just select US code, load generation and concrete design code selection. So from here you select the year. I will use the 2014. So after that you click on next. Next one is the geometry. So these are the things we are going to go through. The first one is vertical vessel job, which we have done. The second one, this one is geometry. After geometry, we move to Anchorage Geometry. After Anchorage Geometry, we go to primary load cases, like that, wind load generation, time period, seismic load generation, and load combination before we do design parameters and do design proper. Okay, so now the units here we use meters. Okay, so now say vessel geometry, effective diameter. So if you look at the preview, it will help us to know the actual place that they are referring to. DVE is the diameter of the vessel. So what was the diameter of the vessel? So the vessel you are designing for, so the diameter of it is mostly found in mechanical drawings. So or fabrication drawing, to show you those information. So I will just use 1.6 as the diameter of the vessel. Okay, so effective height, that's HV, that's the height of the vessel. So I'll put 20 meters. Then diameter, DF, which one is DF? DF is the base of the footing. The base of the footing, I'll put 2.8. Okay. Plan increment 2.8. I'll put maybe 4 meters maximum here. So if you click on any cell, you see the description here. You say minimum diameter of footing, distance between two parallel sites in plan view. So this one is maximum diameter of footing. So any cell you click, it tells you what it is here. Height of vessel from top of pedestal to top of vessel. So that's that. So plan dimension, one is diameter increment for octagonal footing. So plan increments, obviously I'll use 0.8.1. What's wrong with it? 0.1. Okay. Footing thickness, I will use 0.4, maximum of 0.5, thickness increment 0.1. Okay, so foundation type. So here you select either octagonal foundation or square foundation. If it's octagonal, you can just choose octagonal. If it is square, you click on square. So but I will use octagonal. I'll use octagonal foundation. Then foundation support type, is it by soil or by pile cap? Okay, so if it is pile cap, you choose this one. If it's not, see the pile, So if it is not, you choose soil foundation. So I will use soil foundation for today. Okay. Then pedestal geometry. So DP for pedestal is the pedestal diameter. Okay, so I will use of course this is the diameter of the vessel. The pedestal diameter has to be bigger than the vessel, so I can use 1.8, 1.9. Okay, and the thickness, as the height of pedestal, 1.5. Okay, then elevation, bottom of footing. Okay, the elevation, so this one is based on your side grading, the elevation of bottom of footing. So you get that from your grade levels. So you can put what it is here, that 50, 100, 40, anything, grade level, just put 200 there. So depth of water, I will just put 1 meter. So this one you get this information from your geotechnical reports. Soil depth TS, that's the soil depth on top of foundation, is okay. Let me use 1.5, 1.3, 1.2. Sorry, I'll use 1.2. Okay, so I'm done here. I'll click next. So this next one is Anchorage Geometry. So I will still use my meters. Anchorage Geometry, both circle diameter. So the diameter of my vessel is 1.6. Okay, and the diameter of my pedestal is 1.9. So I can use 1.7 as my boot diameter. It's 1.7 here. 1.7. Number of anchorage, put 8. Boot diameter, put 22. Anchor bolt effective embedment depth, I'll use 650. Okay, click next. Next one is primary load cases. Okay, how you choose kilonewton. Moment is kilonewton meter. Okay, from the vendor drawing of that equipment, every vertical equipment has vendor drawing. They will specify the dead load, the empty weight of the equipment, the test weight of the equipment, the operating weight of the equipment. So from there you determine the life load and the rest of them. So they also have the lateral forces, which is base shear, and any possible overturning moment, so I'm going to be assuming the values, but you're going to get all these values from vendor information, all the load data. We call it foundation load data. Okay, so I'll just put -70 as vertical empty dead load. Okay, then operating dead load and test dead load. These two is only one if you use among the two, operating and testing. Anyone that is higher, you subtract the empty weight from it. That will give you a live load. Okay, so I can decide to put that one here. Live load of, let me see, minus 50. Okay. Okay, you can include the the live load during operation. There might be a base effect, that's shear lateral load. Then erection dead load, you can just put value here. All these load data have to be clearly stated on the vendor drawing, so you don't need to manufacture any load yourself. Okay, so click on next. This one is wind load generation. So is either you choose user defined wind load, or you click on program generated wind load according to a particular code. So I'm going to use program generated. From here I will choose the code, which is ASCE, American code. Okay, so wind speed have to be in, use 35.6. Okay, all these ones now have to follow. So these are the code references on how these values were gotten. The code references. So after that, I'll click on next. So this one is time period. So this feature is currently not available. So I'll just click on next. Okay, so it is up already. This one is seismic load generation. So you can use direct input seismic load or mass table CG, or you use program generated. So I'll simply use program generated. Yeah, it's and then from here, seismic group motion values. Instead of using enter value manually, we use select zip code. Okay, that's that. So I'll click on next. So this one is a load combination table. So I'm going to select the code for that, which is this one. Let me use this one. Okay, for load combination, it's going to be automatically generated. You can edit from here and update table. Okay, so I'll click on next. This one is design parameters. Okay, water density 9.8. You can leave it like this, or you put 10. Concrete density. Okay, this one is 25. Put 25 there. Soil density as the bearing pressure. Okay, not bearing pressure, soil density. You can use 18. This soil density, you can find it from geotechnical report. Okay. Base value of soil bearing capacity. Okay. soil bearing capacity. Let me use 100. Bar type, okay. Concrete design parameters. So this my FC have to be 25. Minimum diameter of bar, we use 10. Minimum bar spacing as 50. Cover, okay. Can have 50. Steel strength 410. Maximum bar in mm, okay. Okay, so we can as well go back to design. Go back to edit to verify our inputs, whether if anything has changed. Maximum bar spacing in mm 300. Okay, then I'll click on edit. Then we'll design. We have to save the work. So you can just save it. Vertical version 02. So save.